Hello, this is episode 2 of the WashbearyPi project. Today we're going to control the electric motor in the washing machine with our Pi. For this purpose we need an AC switching circuit. So here you see my first prototype of it. And this is the corresponding circuit diagram. So I'm using a BT139 triac as the front end switch for my electric load. And this triac is gated through an MOC3081 optocoupler. So this provides galvanic separation between the hot part here on the right that is connected to line voltage and the low voltage part on the left that is connected to the Raspberry Pi. The emitter inside this optocoupler is switched through a transistor in order to keep the current drawn from the GPIOs of the Raspberry Pi low. With this 10 kilo ohm resistor here, it is far below 1 milliamp, which is perfectly fine. Now for some of the actuators in the machine, which are just turned on and off, this would be perfectly fine. However, for the electric motor, we want to have a kind of speed control. And here in this diagram, I'm illustrating how this is usually done. So here we have the sinusoidal AC line voltage. And usually the phase cutting technique is applied, which is illustrated here with the red curve. So you are cutting away a certain fraction of each half wave, igniting the triac here. And only the later part of this half wave is then passed on to the motor. Accordingly, the later you give the ignition pulse to the triac, the lower the power to the motor will be. Now, this is something that I presently can't use on my circuit for two reasons. First, I have no zero crossing detection implemented yet. And second, there is a quite inconvenient property of the MOC3081. It has a built-in zero crossing detector, and this device will not ignite when there is a voltage of a bit more than 10 volts in between the two terminals. So I can only turn on my load up on a zero crossing, but not in the middle of a half wave. So this still needs to be implemented at a later time. For the moment, I'm applying a different method of controlling the power to the motor, which I call the half-wave selection method. Guess this is not the official name for it. So what I'm doing, I'm just selecting a limited number of half waves that I'm sending to the motor while cutting off all the others. And also that way I can achieve a speed control of the motor. So let's test this. Here I have a simple test program, which I'm now going to run on my Raspberry, which is wired to the AC switch through those three wires here. Now I'm gonna test the start program, so let's see what the motor does. And you can see it actually starts spinning, but the spin up is rather bumpy, and still a few seconds later you can see that the whole motor drum assembly is shaking. So in principle, yes, speed control is working, but it's quite bumpy at the moment. It turns out that at higher motor speed, this is a less severe issue. So let me quickly remove this line here from my source code and save and recompile. Now I'm going to add an acceleration ramp to accelerate the motor up to full speed. Now let's test this. So again, I'm starting the program. Here you see the bumpy acceleration again, the motor is heavily shaking. It's getting a bit better with increasing speed. And soon my program will switch to the next level. So now you see speed level 1, motor is getting faster. And the speed ramp is continuing, speed level 2, speed level 3, speed level 4. And now finally we're switching to maximum motor power for 10 seconds. And finally power off. So program is done. Motor is finally spinning down. So you can see even with this simple circuit it's possible to control the motor speed. However, I will finally go for the phase cutting method because the initial acceleration is still quite bumpy with that circuit. And here the motor stops.